Okay, hey guys. I'm going to quickly go through notes 3 here. Kind of as we've done with the last couple, I'll probably skip over several of the examples, and spheres are pretty straightforward, so should be pretty quick. At the top here, we've got just a couple vocab things to make sure we know for spheres. Several of these you know. Let's see, we've got the center of the sphere. That's what this one is pointing to here, which is just the center point of the sphere. We also have a radius of the sphere that you see here. I'll try to color coordinate these here. So we've got that's our radius. Then we also have a diameter of the sphere that goes through all the way across, just like we're used to. And the last one is the one that's a little bit new that you may not have heard before. This last one is actually this circle that goes all the way around our sphere from front to back. You can kind of think of like if you're picturing the Earth as a sphere, the equator that goes around the Earth is like a great circle. And that's what that is here. This is a great circle of our sphere. The definition of a great circle is over here. A great circle basically splits a sphere into two hemispheres. It cuts it in half. The one shown here is cutting it horizontally, kind of like the equator. You could also cut it vertically, if you think of like the prime meridian on the Earth, or it could also cut it diagonally, right? So any two-dimensional circle that goes through a sphere has to go through the center of the sphere and cuts it into two hemispheres is a great circle. Okay, so we've got a couple formulas over here for volume and surface area of our spheres. Our volume right here is 4/3 pi r cubed. And then we also have one for the surface area of our sphere, which is pi r squared. Right? I'm not going to go through too much on where those come from. If you want to know, feel free to ask me. I can go through it, but they're pretty straightforward, 4/3 and 4. And again, these will be on your formula sheet when you guys take this test next week. So we just have to make sure we plug in the radius on both of these. So on these first two, I'm just going to look at number 1. We want to find the volume of the sphere. Right, so again, always make sure you are paying attention on the questions. Make sure you know if it's asking for volume or surface area. So on this one, we're looking for surface area, or I'm sorry, volume of the sphere. So I'm going to do 4/3 pi r cubed, and our radius in this case is 7. So 4/3 pi times 7 cubed. 7 cubed is 343, and then that is not divisible by 3, so I can't really simplify anything, so I'll just do 343 times 4, and I'm going to get a final answer of 1372 pi over 3, and that was inches cubed. So there's the volume of our sphere. Right, pretty straightforward there. If you know the radius, just plug it in. Okay, same idea for surface area of a sphere, but now I'm going to use my 4 pi r squared to get my surface area. So let's say, let's look at number 4 on this one. So again, I'm paying attention here that I'm going to do the surface area of my sphere. So formula for that one is 4 pi r squared, right? And this one, notice this time we've got a diameter of our sphere. And notice it's not going straight up and down. It's not going horizontal. It's on a diagonal, but that still counts as a diameter of our sphere. So if I want my radius, it's half of that. So my radius is 12. So to get my surface area, I do 4 pi and then 12 squared. That would be 4 pi times 144. And then if we do our 144 times 4, we get a final answer of 576 pi and millimeters squared. Okay, so again, pretty straightforward. Just got to know your radius, plug it in, go from there. Okay, after that, we also have some formulas for a hemisphere, right? Hemisphere is half of a sphere. And so if I'm thinking of volume of a hemisphere, well, volume is how much it holds, right? So volume of a hemisphere would just be half of the original volume. So if my original volume up here is 4/3 pi r cubed, well, half of 4/3 is 2/3. So the volume of my hemisphere is 2/3 pi r cubed, right? Okay, so let's do this first one here. If I want the volume of this hemisphere, I'm going to do 2/3 pi r cubed. My radius is 5 in this case, so 2/3 pi 5 cubed, which is 2/3 pi times 125. Again, I can't divide by 3 there, so my volume is going to be 250 pi over 3. And we had kilometers cubed this time. Okay, so hemisphere is just half of the volume, right? Okay, for the surface area of a hemisphere, right? So on these down here, we're finding surface area of a hemisphere. And again, I've got a formula here, but notice my original surface area is 4 pi r squared, but surface area of my hemisphere is 3 pi r squared. It's not half, right? We would expect it to be 2. And the reason for that is that we are cutting our sphere in half, right? And so I do want half of that surface area that goes like around the edge here. But then I also have now, when I cut my hemisphere in half, I now have this flat space on the top that didn't exist at all before. So that's another circle. That's another pi r squared. So that's why we now have 3 pi r squared to get the surface area of our hemisphere. Okay, so if I want surface area of the hemisphere, we'll go with number 7 here. Surface area is 3 pi r squared. My radius, again, notice it's at kind of a diagonal here, but that still counts as a radius, right? It doesn't have to go straight up and down or horizontal. Radius in a sphere can go any direction. So then I just plug it in, 3 pi 14 squared. So that's 3 pi times 196. And if we do 196 times 3, that gives us a final answer of 588 pi yards squared. And there is our surface area of the hemisphere. Okay, so these are pretty straightforward. We don't have to worry about like our Pythagorean theorem. We don't have to worry about 30, 60, 90 triangles or anything on these. Really, the hardest thing you have to do on the spheres is see the diameter and cut it in half to get your radius. And then just make sure you're paying attention. Am I finding volume or if I'm finding surface area? And is it a whole sphere or is it a hemisphere? Okay, couple applications down here. We'll do at least one of these here together. So let's look at like number 9. This one says I want to find the volume of a sphere, right, with a great circle area of 201.06 square inches. Okay, well, I want to find the volume of a sphere. To find volume, I need to do 4/3 pi r cubed, right? But in this problem, they're not giving me a radius. I don't know what the radius is. What they have given me here is a great circle area of 201.06. Well, a great circle, remember, is just a circle. So area of that great circle, right, would just be pi r squared, just like our regular circles. And since I know that area, I can plug it in. So 201.06 equals pi r squared. And now I can solve for r, right? I divide both sides by pi. And since that's a decimal, I'm going to go ahead and keep it a decimal. So 201.06 divided by pi gives us 63.999. It's a whole bunch of nines. And that's r squared. And then if I take the square root of that, I get like 7.999, which is pretty much 8, right? So our radius is 8. now I can take that and I can put it over here in my volume formula. So I can do 4/3 pi 8 cubed. If we do our 8 cubed, we get 512. So 4/3 pi times 512. That is not divisible by 3. So again, we'll just multiply it by 4. And we get 2048 pi over 3. And we've got inches cubed. Okay, so I can use that great circle to find my radius. Once I've got a radius, I can find my volume. The other two applications on here, you've got some kind of compound figures, right? So this one here, I've got a cone sitting on top of a hemisphere, and I want to find the surface area of that. The one to remember here is that this circle in the middle here, I don't want to count that because I don't have to think of, if you're going to wrap it in wrapping paper, I wouldn't have to cover that, right? So when you find the surface area of that, you really just want the lateral area of the cone, and then you only want this outside part of your hemisphere. The other one, it's asking for the volume of this kind of compound figure. So I've got a hemisphere on top and then a cylinder on bottom. Find the volume of each of those, and then we can just add those two together. Okay. All right, so you've got your homework number 3 that goes with this. It's just some practice on spheres. As per the usual with the others, you can do just the odds or evens of the homework to get full credit, but if you want to do all of the problems, feel free. Send me messages if you got questions or anything. You can spend some time today working on your homework 1 and homework 2 if you're behind on those. If you're all caught up and you're feeling good about this stuff, remember that there is a Delta Math final review. You can start working on that as well. And I will see you guys on Monday or Tuesday, one of the two? Tuesday, right? Tuesday we'll take our quiz over this unit and groups like we have been, and then we'll have a review day, and then test over this stuff is on Friday. Remember, I will give you all the formulas for this one. Have a lovely weekend. See you guys.